Hey guys, what's up? We're back doing some more lead code. Today we're doing this awesome thing called dynamic programming, and I'm gonna show you guys a super simple but a super awesome problem. So like this kind of blew my mind, I'm not gonna lie. So I'll code this out fresh for you. I want to show you the solution. And actually, now that I look at it, my camera is covering up the left part of the screen. I wonder if I can. Is that better? Maybe. Okay. So this problem is called climbing stairs. All right, and essentially it's a DP problem, and what it does is you are asked, you're given a number of steps, like you're given n steps, right? And the question is if you can climb up one step at a time, or if you can climb up two steps at a time, in how many ways can you reach the goal n? So just for an example, right? So that means that if you had 100 steps, and say I told you that you had to climb 100 steps, and you could either go up one step or you could go up two steps, but like skipping one step, right? So in how many combinations can you reach the top? So that means is all ones is a possible answer, like you just go one step every time. Or maybe you go up to one step for 98 and then two at the end. That's a possible combination, right? Maybe up to 96 and then two twos at the end. That's a possible combination. Maybe you do all twos, maybe a couple of twos, couple of ones, and couple of twos again, right? The question is, in how many patterns, or like in how many combinations of steps, or like in how many sequences can you reach the top, right? Now this is a problem that can be solved very easily with dynamic programming, but if you don't know what that is, it's going to be pretty difficult for you to come up with a solution for this. So even if you try and like come up with the brute force for this problem, you essentially have something like, well, okay, I can either do all twos, let's say the maximum denomination. So it didn't have to be one or two, it could be like 1, 2, 3 or 4 and then 5, and then in that case, if I said 100 and 100 steps was your goal, and then you could either go up 1, 2, 3, 4 or 5 steps, then you would devise some kind of algorithm where you tried the maximum first, where let's say 5, all 5s as far as you could, right? And then 4s, and then 3s and 2s and 1s, and then maybe like all 4s as far as you could, and then possible combinations in between here and there, and then like it's just too complicated. Like you won't even be able to come up with a brute force for this unless you have the intuition for this problem. But using this amazing trick called dynamic programming, we can solve this with basically one line. All right, check this out. So this is a base case. So if we have one step, there's just one combination. That's kind of an edge case. So what we're gonna do is we're gonna do essentially, let's say climbs. We're gonna make a new array in 200 DP for dynamic programming. Okay. We made a new array called DP with a length of 1 more than what was the length of the thing. What was the length of the input array, right? Or rather, 1 more than the count number of steps, right? And then what we're gonna do is well, you can see me anyway. Doesn't really matter, but okay. So yeah, okay. So we make a new array, and then we're going to initialize, say, dp1 equals to 1, and we're going to do dp2 equals to 2, right? What that means is, for step 1, there's only, okay, so before I code the solution, I'm just gonna give you the intuition about how to solve the problem, right? Essentially, if you, okay, so it's actually kind of mind-blowing how you solve this problem. So if you are on any step in between 1 and 100, there are two ways you could have reached that step. You could have reached that step from step -1, or you could have reached that step from step -2, right? Think about it. Those are the only two ways. And now, given that, we're gonna do this mind-blowing thing where we run a loop, and we run the loop from I equals 3 to I less than equal to n, which is, say, 100. And inside the loop, we're going to do dpi equals dpi minus 1 plus dpi minus 2. Right? Turn dp add dp n. Right? So what we've essentially done is we've said that, let's say step 50, right? So you could have come to step 50 from step 49, or you could have come to step 50 from step 48, right? So if I ask you the question, in how many ways can you reach step 50? You're going to say that if I can come from step 49 or step 48, then my answer is the number of ways I could reach step 48 plus the number of ways I could reach step 49, right? Because I could either come one step or two steps. So the number of ways I reached 48 plus the number of ways I reached 49. That's the total number of ways I could reach step 50, right? And the same thing is applicable for any steps between 1 to 100, 1 and 2 being the base cases, because it's like 1 for 1 and then 2. 2 is 2 because you could go to 2 by 1, 1 or just a direct 2 directly. So it's like two combinations. So it's like 1 and 2. And then you basically apply this formula from 1 to n. And then if I do dpn, accepted, solved, faster than 100%, right? That's literally it. You just kind of count the things again and again until you reach the end of the array or the end the target number, right? This is actually very similar to the Fibonacci sequence, if you know what that is. It's very cool actually, how you solve this problem. If you don't know the actual answer, or if you like don't know the actual approach, you might be thinking like a lot of stuff. How can I come up with like so many combinations? But it's essentially like very simple. So I think the idea of dynamic programming is to have sub problems which you can solve and then use to find the main answer, and so you don't really need to recompute the solution to the sub problems every time, and like hence you save time. So yeah, in essence, that's it. One liner, and you have the solution. For someone who has never seen this problem before in their life, or for someone who doesn't know dynamic programming, this could be quite challenging, but once you see this answer, like your mind is just completely blown. You're like, what magic is this? Insane. But anyway, that's been it for this video. Leave a like, subscribe, and I'll see you guys in the next one. Bye for now. Have a great day.